you, Tony. Peter Jager I'm an engineer. We talk today a little bit about our application and our snowplow connected deployment.
Hey, Peter, your audio is a little bit skippy. Maybe a little closer, a little further from the mic.
How's that? Any better?
That's better. Thank you.
Great, thanks. Go ahead and launch the next slide and give you a little background here. Our connected vehicle deployments. In 2017, we started with a transit system priority. We had a willing partner in our transit agency let us put some devices on their buses and see if we could get the schedule more reliable. We worked on a transit signal priority, giving the early green or extended green lights buses when they were more than 5 minutes late, trying to get them on schedule and stay on schedule. Using the same DSRC technology on that same corridor, we put onboard units on snowplows to give them signal preemption. They would get a green automatically every time. So you can see on the map 2017, click through the other blue dots on the map, are locations where we added more roadside units from our snowplow routes, about 5 corridors around the Salt Lake Valley. And during this time, 2018, there was a BRT route being constructed further south in Provo. You can see at the bottom of the map, Provo-Orem area. So already having the roadside units in place, we were able to equip snowplows there and expand the system down there. So the snowplow system went live in 2019 up north, and a little bit later in late 2019, the following winter in the south. So we had to click through the slides, 131 roadside units and 86 total onboard units between the buses and the plows. Here's a look at the roadside hardware. You see at the top left there, roadside unit, that basically an antenna mounted on the traffic signal mast arm. And so with the antenna there, it's connected to the signal cabinet down below by a Cat6 cable and into a Linux-based signal control module inside the traffic signal cabinet. And from there, it connects to our statewide traffic fiber optic network, back to the traffic operations center and the signal control software. And over on the right, you can see the onboard units. The buses had a large server rack. They're in the top of the slide. But the onboard unit itself is pretty small, so we were able to mount it easily in the snowplows, either under the seat or under the dashboard or behind the passenger seat. You can see some snowplow controls there, the spreader and the plow equipment. We programmed the system to work connected through the spreader. We had some technical issues connecting it to the plow up or down, so the signal preemption would only work when the plow was actively spreading salt or brine. That way the system is only used when they're actually actively plowing snow. So basic look at the snowplow operations here. When the plow comes into range of the DSRC, the plow is continuously broadcasting the basic safety message, or the BSM. It's also receiving the SPAT and MAP data, the signal phasing and timing. So as it comes into range of the traffic signal of the roadside unit, the GPS reports the plow location, and the software called MITS determines the plow location in the lane and the distance to the signal. It sends a preemption request to the roadside unit, and the preemption request goes to the signal controller. It can process that request. It can't send a message back to the snowplow telling it whether it's going to get a green light or not, based on limitation. It just confirms that the message is received. So the onboard unit on the plow knows the message is received, but the driver is instructed. The driver has no interaction with the system. It's all automated in the background. So the driver is instructed to follow the traffic signal display that they see, follow the red, yellow, or green. So it all operates automated in the background. They don't get any kind of a magic button or remote control of the traffic signals. So our initial project here in 2019, 5 corridors, 55 intersections here. The red dots were the initial transit corridor on Redwood Road along the west side of the valley, and the blue dots were the additional intersections we equipped for snowplows. They went live in March of 2019. Right at the end of winter, we caught one of the last big snowstorm and a little bit of another storm. So at least got to test it that year. And phase 2 went live, was finished. Only required 5 more traffic signals to be equipped and the 10 snowplows for the maintenance area and the Provo-Orem area. So both projects were ready for the following winter of 2019 and 2020. Here's a look at the user interface. This is an online interface built by our local contractor to help us monitor and troubleshoot the system. The yellow dots you see on the screen is the plow moving up and down the corridor, or a bus in the case of tracking buses. And they leave behind cookies on the map, the blue and the orange dots, so you can track it. If snowplow is reporting, not getting any preemptions, we can go watch it live on the screen here and see if it's tracking, if it's sending and receiving the messages as required, the signal request message or the signal status message. So there's a lot of detail on the screen here, but that's what it's letting us know, monitor and troubleshooting. So feature of the project, we received an ATC MTD grant a couple years ago, supported UDOT to expand its RV2I applications. And so we're adding more snowplow routes and in the southern part around the Provo-Orem area and further in that Utah County area. Routes will be integrated into the next phase of our connected vehicle ecosystem project currently underway. The system has proved to be quite popular with the drivers. You can imagine not having to stop for red lights is pretty good benefit. But the drivers have reported other benefits, just generally feeling safer. They don't have to worry about sudden stops. They can continue maintain a safe speed, continuous speed. They can plow side by side in platoons and get the left turn lane and the through lanes at the same time, not leaving big piles of snow at the intersection when they stop. Generally more effective, and getting the road clear faster helps the general public. There is some impact when you preempt a signal to the cross streets, but generally the impact is pretty minimal. We're able to recover the coordination cycle within 2 cycles, or about 3 minutes. And the benefits of clearing the snow sooner and getting traffic moving again proved to greatly outweigh the cost of disrupting the coordination patterns. So here's a look at our overall connected vehicle deployments we've been working on. Our connected vehicle ecosystem project is with Panasonic. Up in the top right, the orange dots was the initial ecosystem deployment through Parley's Canyon, Interstate 80 there. We equipped vehicles and the roadside with units to collect data, get insights from vehicle travel patterns. This is related to weather because we could identify when the wipers were on at higher speed or low speed, identify a traction control engaging sudden stops or sudden drops in speed on that corridor. And this processed in the software could give us more insights of the weather in the canyon, help the operators back at our traffic operations center know messages to post on the variable message signs. Eventually, we hope to use this information to get information directly back to drivers on an on-screen display in a vehicle, real time to where they're at. So if they've already passed the VMS on the freeway and they're entering the canyon, they can still get real-time warnings about weather and road conditions. The vehicle sensors can also send crash indications back to our traffic operations center. Say if they slip on the ice and crash and the airbag goes off, that airbag deployment sensor can immediately alert the traffic operations center, hey, vehicles crashed, the airbag went off, we need to dispatch there. Other applications we're working on with this ecosystem are curve speed warning and other applications be developed using the data analytics, sharing the data with other companies. The spot weather impact warning, as I mentioned, is something we're looking at in the canyon. Those orange dots right in the middle there is another canyon road that connects to 2 ski resorts in the Salt Lake area. So you can see that S-curve up there. That is that orange arrow right there pointing downward. That is the S-curve in the picture right next to it. So that is could be a treacherous area in the winter if the roads are slick. So the total deployment for this project was 69 roadside units and 35 vehicles in the UDOT fleet. Other additions, other applications as I mentioned, the transit signal priority. We're expanding the snow plow and emergency vehicle preemption further south there. The green dots, if you see in the lower part of the map, the green dots arranged in a square, that's the city of Orem. We're equipping currently all of the traffic signals in that city. And it will be equipping the city's emergency vehicles with preemption capability, the snowplows and the emergency fire ambulances. And they will be testing the data collection with their fleet vehicles as well to gain more vehicle insight. And further along the corridors to the north, those green dots will be more snowplow corridors. You'll get a signal preemption along those critical routes that were identified by the maintenance region there, where they needed the most help, particularly along the west side of the Utah Lake there and up north, leading into the canyons there. So the total deployment here will be 138 roadside units and 150 onboard units between the buses, plows, and fleet vehicles. Okay, next. And we have future deployments planned here in Salt Lake Valley, that red line running east-west, a corridor requested by the transit agency. And in the upper map, a new bus rapid transit corridor being built right now. These will be able to serve both transit and snowplows connecting these areas. Now, due to frequency changes by the FCC, all of our original deployments in blue dots there were built with DSRC. Our newer corridors being built this year are using cellular V2X and dual mode units. But as DSRC is being phased out over the next 2 years, we will need to replace all those roadside units in blue with cellular. So we'll work around the valley at each maintenance station, update their plows and upgrade the roadside units. Fortunately, the software will largely remain the same. The major expense incurred here was developing the software and integrating and testing the process. At this point is more of just a hardware change to the unit. So our snowplow program will continue just with a different technology. Yeah, there you go. See, the next 2 years we'll be replacing DSRC on these corridors. So a look at the effectiveness. We engaged BYU through our UDOT research program to do a research study on the effectiveness of the snowplow preemption. Said here the study is about to be published. I think it went live yesterday, so can't find it. But results, the qualitative results were excellent. Like I mentioned, the drivers are very happy. They found a lot of benefits to more efficient plowing, more faster clearing the road. The amount of preemptions on the signal were very few. There's typically once per hour during a storm, and if the storm is an hour or two, it would not be a lot of disruption to traffic. But however, trying to compare two roads, one road dry and one road with the storm, or two roads similar, there's so many variables, different types of storms, different amounts of snow. They found statistically comparing one storm to another to be very challenging to get good results. We did see a reduction in crashes and feel like there's general improvement in safety. But we'll continue more research, more comparison as this goes on. But in general, drivers, operators, and the department were satisfied with the system so far, and we'll continue with the expansion.